As we have discussed earlier the concept of ratios, today we extend the concept of ratios by discussing the concept of equivalent ratios. As we know that ratio is another form of common factors. So here we have a rule that basically govern the concept of equivalent ratios. Let's see what is the rule. According to the rule of equivalent ratio, if we multiply, or if we have, for example, if we have a ratio, let's say 2 is to 3, and we multiply and divide both the elements by the same number, by the same number, then the value will remain same. Value will remain same. Okay, let's see how is it. How is it possible? For example, you have a ratio of 2 is to 3, and we multiply 2 is to 3 with 2. It means if you multiply one element with 2, then you have to multiply the another element with 2 as per the rule of math. Here we get 4 ratio 6. It means that this ratio value is same as this ratio. They are same. It means if you have 2 is to 3, you have the ratio of 2 is to 3 between the two quantities, or you have the ratio of 4 is to 6 between the two quantities, then they have the same value of ratio between the two. Let's take another example. For example, you have to find equivalent ratio of 3 into 3 ratio 4. 3 ratio 4. What you will do? For example, if I give you the options, one option is 21 ratio 36. Okay. Another option is 15 ratio 20. Another option is 12 ratio 16, and another one is 18 ratio 12, and the last one is 16 ratio 12. Let's check them one by one, that what is the equivalent ratio of 3 ratio 4. So first we will see, if we multiply 3 with 7, we will get 21, and multiply 4 with 7, as we have to multiply the same digit on the both side, then we get 21 ratio 28. As there is no value of 21 ratio 28, so we will say this is not the equivalent ratio of 3 ratio 4. Next, if we see that 15, now we will check about this. 3 5s are 15. It means we have to multiply 5 on both sides. 3 into 5 ratio 4 into 5. 5 3s are 15 and 5 4s are 20. Okay, so it means that this is the right equivalent ratio of 3 ratio 4. Let's check that is there any other equivalent ratio in the list. Next is 12. 3 4s are 12. So we can multiply 4 on both sides. 4 into 4, it will be 12:16. Yes, it means this is also the equivalent ratio of 3 is 3:4. Next we will check 18 and 12. 18, 3, 6 are 18. It means we will multiply by 6 on both sides. 4 multiplied by 6, it's 18 and it's 24. It means this is not the right equivalent of 3:4. Then is 16 is to 12. As we have already seen in the third option, we have 12:16. It means that we cannot consider as 16 is to 12 because the order of ratio matters in while we calculate the ratio of the two quantities. That means 12:16 is not equals to 16:12. It means the equivalent ratio of 3:4 here are 15:20 and 12:16. So hope so you have got the concept, a clear concept of equivalent ratio by understanding this example. Let's take another example. Find an equivalent ratio of find equivalent ratio of 5:3. Okay, let's see the options. We have the options of 15:9, 10:9, then 20:30, then 35:27. Now let's check them one by one again. For 15:9, we have to multiply the 5 with 3. It means 5 into 3 ratio 3 into 3. That is 15:9. Yes, it means this is the equivalent ratio of 5:3. Okay. For 10, we have to multiply for the next option. We have to multiply 5 with 2 and 9 with 2. It will be 10:18. It means this is not the right answer. Again for 20 we have to multiply by 4 on both sides. 3 into 4, that comes out 20:12. It again we will not take this one. Then 35 into 27, it means we multiply 5 with 7 and 3 with 7. It means 35 and 21. Here again it is not satisfying the condition. It means the only equivalent ratio of 5:3 is 15:9. So hopefully these two examples have cleared your concept of equivalent ratio.